Hello and welcome back. So over the past few videos, we've been trying to do nodal analysis. We've been learning about nodal analysis, and the last bunch of videos we've been dealing with this circuit that only had two nodes. And we solved it, and we simulated it, and we checked our work and everything. And now what I'd like to do is I'd like to move on to a slightly more complicated circuit. And what we're going to do in this video is we are going to look at a circuit where we are going to have three different nodes, and we are going to need, or actually we're going to have three different nodes, and we learned in the past couple of videos that we always write equations for the nodes in our circuit that are not the ground node. So we are going to look at a circuit that has three nodes, so therefore we should end up with a system of two equations and two unknowns in this video. So let's go ahead, and I'm going to get to a clear spot on my digital paper and go down a little bit more, even more, and let me go ahead and draw a circuit. Let's say, and I'm going to stick with current. Actually, you know what? I'm not going to stick with current. I'm going to use voltage sources as well. Where am I? Actually, yeah, I am. I'm going to use voltage sources. So let's just go ahead, and I am going to, yes, I'm going to use a voltage source, and I'll have a resistor here. Let's say that is 6 ohms. Let's say I've got another resistor here that is 4 ohms. A resistor here, which is, I don't know, 12 ohms. And then I'm going to come down here, another resistor, and this is going to be, I don't know, 15 ohms, 15. And then right here, I'm actually going to put a current source which is, let's say, oh, and I still have to label my voltage source. Let's say my voltage source, let's actually give it some interesting number. We always do 5 volts and 6 volts. Let's actually say that this is putting out 3.3 volts. So this is putting out 3.3 volts. It's kind of like some Arduino boards put out 3.3 volts, and that's actually a pretty typical digital voltage. So let's say that this is 3.3 volts. And let's say that this current source is putting out, I don't know, let's say it's putting out 1 amp. So this is putting out 1 amp of current. And what we want to know, let's say I want to know what is, oh, and let me also give myself a ground node. I'm going to say that my ground is right here. And let's say that what I care about is I want to know what this voltage is right here with respect to ground. So this voltage, so that's going to be, I'm going to call this V out. So that, or actually I'll still keep with calling this V0. That's the positive side of V0. That's the negative side of V0. I want to know what V0 is. And let's say that I also want to know what this current is. And I'm going to call this I0. I want to know what the current is that flows through this 12 ohm resistor. So anyway, that's the problem. I'd recommend, or actually no, I'd recommend, if you want to pause the video here and try to see if you can work through this on your own and write the nodal analysis equations, it's a really good idea. It's kind of always a really good idea to try to pause it and do it on your own and then unpause it and, see if what you did worked out. But anyway, what I'm going to do now is I'm going to do nodal analysis on this circuit. So the first step that I'm going to do in this problem is I'm going to label all of my nodes. And the way I like to do this is I actually like to color in each of the different nodes. So I'm going to start with this node. So everywhere here is all going to be at the same voltage. So that's how I'm going to color this in, because everywhere here is all at the same voltage. And I'm going to call this V1. So that's my V1 node, because it's all at the same voltage. Then I'm going to go over here. I'm going to color in everything over here. And notice that with respect to ground, that this voltage over here I wanted to know what V out is, what V0 is. So I'm just going to go ahead, I'm just going to call this node my V0 node. That's what my V0 is going to be. And then I've got this node in here. So I've got this node in here everywhere along this whole section. That's all going to be the same voltage. So I'm going to call that V3. So I've got 3 different voltages, and then one last thing, can't forget, is that I have my ground node. So my ground node here is all at the same voltage, and that voltage happens to be 0 volts. So that's my ground node, and this is 0 volts because it's connected to ground. So that's the first step. I just identify all of my nodes. I personally like to color in the different nodes, so if you have color pencils, it might be a good idea. It kind of keeps everything, keeps it very visual, I guess. And now the next step, so after I've colored in all the nodes, is I am going to assume current directions for all of these different elements. And I'm actually going to assume a current direction for my voltage source in addition to all of these different resistors, because the point of what we're doing is still the same. We want to say that the current in to a node is equal to the current out. So we're just going to pretty much define current directions for all of the different elements that we sort of need to define current directions for. The only one that we really don't need to assume a current direction for or define another unknown current for is this current source, because we already know 1 amp of current is flowing that way. That's not unknown at all. We know that exactly. So we know 1 amp of current flows from the bottom to the top in this part of the circuit. So anyway, let's go ahead and start assuming current directions. Let's assume for this 6 ohm resistor that current flows like that. Let's assume for this 4 ohm resistor that current flows, let's say, like this. So 4 ohm, so across the 4 ohm, we flow from right to left. And then for this 3.3 volt source, let's say that current flows from bottom to top. And then for this 12 ohm resistor, let's say that current flows in the same direction as I0. So from left to right. And then let's assume for this 15 ohm resistor that current is going to flow top to bottom. So anyway, I've assumed current directions for everything. One note on this, I'm just guessing about this. There's absolutely no right answer, no wrong answer. I could reverse the direction of all of these. I could reverse the direction of some of them. It completely doesn't matter. It's going to change the way I write the equations, but if I want, like here, I'm just going to, just for the sake of argument, I'm just going to reverse the direction on my 4 ohm resistor, and just to show you that it's completely, it doesn't matter. I can absolutely say I can reverse this current direction and I'll still get the correct answer for this circuit. So anyway, I've assumed current directions for everything, and now what I'm going to do is I'm going to start writing my what goes in equals what comes out equations for each node. Now when I say what goes in equals what goes out equals what comes out, I am talking about the current. The current into every node in the circuit, the current that goes into each node has got to equal the current that flows out of that node. So in the last circuit we dealt with, we said that this is kind of like having a hose. Like if I have, 3 gallons per minute flow in one end of a hose, I have to have 3 gallons per minute flow out of the other end of the hose. Water isn't accumulating anywhere inside the hose. It's not like I have a balloon attached somewhere to the hose. The water that I put into the hose has to equal the water that I get out of the hose. And similarly, it's the exact same thing. The current that flows into a node in this circuit has got to be equal to the current that flows out of any node in this circuit. So now what I'm going to do is I am going to write my current in equals current out equations for for the different nodes in this circuit. And I'm going to start with this V1 node. So I'm going to start right here. So my first equation, and I like to label that with a circle 1, and I kind of put a circle 1 next to it in the circuit to show which node I'm describing. Oh, one last thing I forgot to do. Before I assume the different current directions here, I also want to name them. So let me just go ahead and name these different currents. I'm going to call this I1. I'm going to call this I2 that flows across that 4 ohm resistor. I'm going to call this this current I3, and I'm going to call this current I4. I don't have to call the current that flows through that current source anything because it's sort of like already known. You know, I could call it I5 if I wanted to, but then I5 would just be equal to 1 amp. You know, it's really, you know, I know exactly what it's going to be. So let's just go ahead and I'm just, in my equations, I'm just going to write that as 1 amp. So now, for this first node, V1, let's go ahead and write our current in equals current out equations. So the first thing is what goes into this node. Well, it looks like I3 and I4 flow out, and the only thing that goes in is this current I1. So let's go ahead and just write that. So I1 is what flows into that node. I1 flows in. And that's going to be equal to the current that flows out of the node. So I3 flows out, and I2 also flows out. So I3 flows out, and I2 also flows out. One thing I just want to mention, in tutoring people, I've noticed that a lot of people, if I ask someone to write down all the currents that, if I'll say to someone, write down the currents that flow into I1 and the currents that flow out of I1. Sometimes people want to say, well, I0 flows out of I1. And you can sort of say, well, kind of, you know, it's like the current that flows here, it can't go down here, it has to flow in this direction. You can kind of say that I0 flows out. But what we want to say is we want to only write down the currents that flow directly from our node V1, from our V1 node into another node. So it's like, it's true that I0 has some component of the current that's flowing from V1, but I0 is flowing from our V3 node into our V0 node. It really doesn't have much to do with our V1 node. So we only want to deal with currents that are flowing from V1, from our V1 node, into other nodes when we talk about currents that flow in or out. So anyway, that's our equation for this first node. I don't want to rush this. I'm starting to push my time limit, so I'm actually going to end this video here. And in the next video, we are going to continue with this circuit, and we are going to keep working with this equation just a little bit more. So I am going to end this here, and I'll see you in the next video. Thanks for watching.